Hey guys, welcome back to my CCNA 200-301 course. Patrice is here, and in this video we'll be configuring OSPF. Today's video gonna be a bit longer than the previous one, so grab the choice of your beverage and let's get started. This is our today's scenario. We want to configure OSPF in multi-area design. So we have router 1 and router 2 as our backbone routers in area 0. We have router 7 in area 1 and we have 4 routers in area 2. The reason I aligned routers like this is I want to show you how you can configure OSPF in 2 network types. The first one is P2P or point to point, where you have only 2 OSPF routers connecting directly together through either Ethernet or serial interfaces. And in broadcast mode, which you have multi-access OSPF routers, and those DR and BDR stuff we talked about in the previous video will be important and will take place. All right, we start from our router 7, which is our leftmost router. The first thing I want to do is put the interface in shutdown mode, and once we configured OSPF, then we'll be bringing it back up. To configure OSPF, you have to go to global configuration mode and say router OSPF, and in front of router OSPF, you have to set a process ID. And this process ID can be a number from 1 to 65,535. It's a 16-bit field. And this process ID is locally significant, so it doesn't have to be the same on all involving routers. But I would personally recommend you to set the same process ID on your routers, all of them, to make it consistent. So for example, we say router OSPF 1. And as you can see, our config will be changing to config-router. Now it's the time to define your networks, or the networks that this router will be advertising to other routers, and tell them, hey, other routers, if you want to reach out to this subnet, I'm the person that can help you to do that, which is effectively their connected networks or connected routes. So for this router 10.0.30/24 and also 192.168.1.0/24 are the routes that actually need to be advertised. The command that led us to clarify what networks are reachable through this router is network. And in front of network, you have to mention your prefix. For example, in this case, it's going to be 10.0.3.0. And in front of it, you have to use OSPF wildcard bits. Wildcards are actually the reverse of the subnet mask. So wherever you have 1 in your subnet mask, it's going to be 0 in wildcard and vice versa. So for example, for 255.255.255.0, your wildcard going to be 0.0.0.255. Okay, so this byte was all actually 1, so all ones will be turned to 0, so it becomes 0, and all the way around to the last octet, and last octet is all zeros, and then it will turn to all ones, so it's gonna be 255. For the bytes or octets that are either 255 or 0, it's easy. But when you have subnet masks that are different, like 128, like 192, etc., the easiest way to do it is minus them from 255. So for example, if your subnet mask is 255.255.128.0, your wildcard gonna be 0.0.127.255. So you just need to minus this from 255, and the result will be your wildcard mask. So for this scenario, we have a 24 bits subnet mask. So the wildcard gonna be 000255, and here is where you configure the area ID. So here first we have to mention area and then area ID. So network 10.03.0 here is in area 1, which is the left side of our router. So we have to mention here area 1, okay? And on the other side, network 192.168.1.0 with the wildcard mask of 000255 is in area 0. So this interface is in area 0 because it needs to be connected to router 1. So this setup makes this router an ABR. It's an area border router because it has one interface in backbone area and one interface in its own area, which is area 1 in this case. So when you run this command, two things happening. First is router 7 will advertise this network to the rest of the network, I mean the neighboring routers, and tell them, hey guys, if you want to reach out 192.168.1.0, I can help you out. The other thing it does is it actually starts to send hello messages and start all of that OSPF process we talked about in the previous video on the interface that has this IP address on it. So as soon as you run this command, router will start to send hello messages on gig 2. But since we shut it down, nothing will happen. But so far it had to start the things on this interface because we didn't shut it down, but we don't have any router connected to this subnet. So you may ask, why do we need to have OSPF messages? Because it starts to send hello messages and it will send OSPF messages, hello messages every 10 seconds on this interface. And you may ask, why do we need it? Actually, we don't. So in these circumstances, you have to run this command. This is a must if you want to let other routers in your network to be able to know where to go if they want to reach out to this subnet. So this is a must, but you can disable sending OSPF hello messages on this interface. I'll show you the command later. The other routers will also be configured in the same manner. So in router 1, I go to global configuration mode and go to interface range gig 1 and 2, shut them down first, and then I say router OSPF, sorry, not in the interface mode, in the global configuration mode, router OSPF 1, and then network 192.168.1.0 with the wildcard mask of 000255, and that interface is in area 0, and also network 192.168.2.0, and 2.0 is also in area 0. Router 2, global configuration mode, interface range gig 1 to 2, shut down router OSPF 1, network 192.168.2.0 and 000.255 area 0, and network 192.168.3.0, 000.255 still in area 0. Same things on router 6, interface range gig 1 and 2, shut down, and then router OSPF 1, network 192.168.3.0.0.0.0. This one is in area 0 because it is connected to the backbone area, and network 192.168.4.0 is connected to area 2. Router 3 has only one leg in subnet 4.0. So int gig 1 shut down, and then router OSPF 1 and network 192.168.4.0.0.0.255, and then it is in area 2. Router 4 has two interfaces in the area 2. So interface range gig 1 to 2, shut down, router OSPF 1, network 192.168.4.0.0.0.255, and it is in area 2, and also network 10.0.1.0 with the same wildcard mask and the same area. And finally router 5, again two interfaces, interface range gig 1 and 2, shut down, router OSPF 1 and network 192.168.4.0 with the wildcard 0.0.0.255 area 2, and also network 10 and then 0 and then 2.0, the same wildcard and in the area 2. These commands are the only commands you need to run to make OSPF work. So now if I turn on my interfaces or bring them out of shutdown mode, you can see that OSPF will work. But before that, I want to show you some other commands, and then we'll start our verifications. The first command I want to show you is the router ID. If you remember that, I told you 3 stages will happen for the router to pick the router ID. And the first one is your configuration. So if you configure the router ID explicitly, router will pick it up. So the command that can help you to set the router ID is, first you need to go to your OSPF configuration, same process ID, remember that. And then the command is a router ID. And as you can see, it is similar to IP address format, okay? So for router 5, I want to set 5.5.5.5. On router 4, I want to show you the next step. I don't want to configure the router ID, but I want to configure a loopback interface. So I say interface loopback 0 and set an IP address on it. And that IP address is 4.4.4.4 and then 255.255.255.255, okay? And you'll see that router will pick this IP address as its router ID. And I want to leave the rest of the routers to pick the biggest or the highest IP address as the router ID, so you can see all 3 situations. The next 3 commands are related to manipulating the cost. As I mentioned in the previous video, you can manipulate that formula and change all of the 3 items. The first one was completely rule out that formula and set your own cost. And the second one and the third one are related to the interface bandwidth. You can change the reference bandwidth or the interface bandwidth itself. So you should have figured out the interface related commands need to run on the interfaces, and the one that is related to global setting, which is the reference bandwidth, need to be done on the router OSPF setup. So I go for the first one in the OSPF setup. So we go to our router OSPF and we say auto cost reference bandwidth, and then we set our reference bandwidth accordingly based on the interfaces we have on this router. And for the other two, we go to the desired interface, for example, int gig1, and we can either change the bandwidth and set the desired bandwidth, which is relevant to the service, for example, you got from your ISP, or you can set IP OSPF cost, and then set your cost manually on this interface. And this setup will rule out that formula completely and will set this cost you set on the interface. The next two commands are related to hello and dead interval. As I mentioned in the previous video, these two timers are the ones out of other parameters are the ones that two routers will check if they want to become neighbors, and they have to be the same. By default, hello timer is 10 seconds, which means that router will send hello messages every 10 seconds to check if the neighboring router is still alive. And by default, it is 4 times of hello for the dead interval. So if the router doesn't respond in 40 seconds, this router will be dead and will be considered as dead. But you can change these two timers, but you need to be careful and you have to set it on both ends. So if you change it on one side, that will break the neighborship between the two routers. And this setup is happening on the interface. So you have to go to the interface and you can say IP OSPF hello interval and set your hello interval, or IP OSPF dead interval and set your dead interval. And you have to make sure that dead interval will be more than hello interval, like 2 times, 3 times, etc. By default, OSPF network type is broadcast, which is suitable for networks like this, where you have multiple access and multiple routers are connected to a single or the same network segment. But for these circumstances where you have a point-to-point communication either through Ethernet or any other types of communications, it doesn't make sense to let the router to go through all of those DR, BDR stuff. And we can disable that mode by changing the network type. To change the network type, we have to go to the interface. So for example, on router 1, because both interfaces are in point-to-point network connection, we can select both routers and you say interface range, gig 1 and 2, and then we say IP OSPF network and then point to point. By this setup, all of those DR, BDR stuff will be ruling out, and the routers will not go for that process on that neighbor which is connected to this interface. And obviously we have to do it on the other side as well. So on router 7, I go to int gig 2 and then I say IP OSPF network and then point to point. Same thing on router 2. So on interface range, gig 1 and 2, and then IP OSPF network point to point. On router 6, we have both of them. So on gig 2, the interface, the OSPF situation or network connection is point to point. On gig 1, it is on broadcast. So if we go to interface gig 2 and change IP OSPF network and then point to point, you can set it as the point to point, but we can leave on gig 1 on broadcast, which is the default. But for whatever reason, if you need to set this manually, or if you had the interface on point to point and now you want to change it to broadcast, on the interface you can simply say IP OSPF network and then broadcast. At the beginning of this video, I mentioned when you run network command, it does two things. First, advertise the subnet that is you said in the network command, like 192.168.1.0, or 10.03.0, and also we'll be starting to send OSPF hello messages on the interfaces that are connected to that subnet. In this case, gig 2 and gig 1. And this is the default behavior of OSPF. And it means all interfaces are enabled to send OSPF hello messages by default. And as soon as you configure network command, it will start to sending those OSPF hello messages. To avoid this, or to disable OSPF hello messages on the interfaces that we don't need to, we have two options. First, disable that default behavior. I mean, disable all interfaces by default, even if you have the network command, and then we go to the specific interface and enable it, for example, for router 7 gig 2, or we just leave the default behavior to be enabled and disable it on specific interfaces. It depends on the number of interfaces you have for the OSPF, or maybe it depends on your preference. If you have many interfaces that need to be involved in OSPF, maybe you can leave the default. But if you have like one interface in OSPF and 100 interfaces in non-OSPF situation, it would be better to change the default mode. Okay, to configure the first case, I mean disable all interfaces by default and enable it by desired, I mean on the interfaces that need to be enabled. We go to our OSPF configuration, so OSPF 1, and we say passive interface and then default, and this will change that default behavior. And if we want to enable, and then we have to, if we want to configure OSPF, then we have to enable this feature on the interfaces that need to be able to send the OSPF hello messages. So we say no passive interface, in this case gigabit Ethernet 2. If you want to go all the way around and just disable OSPF hello message sending on specific interfaces, again we go to OSPF configuration, and here we say passive interface, and then for example for router 2 it is gigabit Ethernet 2. So you have these two options to disable or make them passive interface or no passive interface accordingly. As I mentioned before, when we have a multi-access network, or we have like more than 2 routers that are connected to the same segment, then that DR-BDR situation will happen, and one router will become the designated router and the other one will be backup designated router. And I said in the election, the one with the biggest IP address will become the designated router, and the one with the second biggest number will become the backup designated router. This is the default behavior. But again, you can intervene and change this default behavior, and you can nominate your router, the desired router, to be the designated router by determining the priority of your router within that structure. By default, the priority of the routers is 1. So all of these routers will have the same priority, and then the tiebreaker will be the router ID. But you can manipulate the priority, and then you can select the desired router to become the designated router and also the backup designated router. You can select both of them. To change that priority, we go to the desired interface. For example, on router 4, we go to gig 1, and then we say IP OSPF priority, and we can set a priority. Priority 0 means that I don't want this interface to be involved in the election process at all. So it doesn't matter who will become DR or backup designated router, etc. This interface, this router does not need to be involved in the election process. So it will be eliminated from the process, no matter what router ID is set on it. As I mentioned, the default priority is 1. And then the router ID will be the tiebreaker. But if I say, for example, IP OSPF priority 100, then I will be nominated router 4 as the designated router. Okay, so if I run this, you'll see that router 4 will become the designated router when we run our verification commands. In some situations, you may have an edge router. For example, let's assume that router 7 is connected to our ISP and it provides internet connectivity for the rest of the network. And it has a default static route points to the ISP router. In these circumstances, we can configure OSPF to advertise this default route through OSPF and let the others know if they want to reach out to the internet, they can go through this router, and we don't need to set individual default route and point these routers hop by hop. For example, we don't need to set the default route, a static route on router 6 pointed to router 2, and then from router 2 to pointed router 1, and then router 1 to 7 to eventually reach out to the internet. And we let this process to be handled by OSPF, and OSPF advertises this default route to the rest of the network. To do that, we go to our global configuration mode. First, we need that default static route. So we say 00000, and then for example, let's assume that it is somewhere on the other side, and we say 10 0 3.2, and then in the OSPF configuration, we go to router OSPF 1, and we say default, and then information, and then originate. Okay, and this command will enforce OSPF to advertise this default route to the rest of the network. OSPF by default supports ECMP, or equal cost multipath, which means if you have more than one route to a specific destination, we mentioned that OSPF will pick the best route with the one that has the lowest cost. But what would happen if all of those paths have the same cost? Okay, in these circumstances, these routes are equal cost. So OSPF will load balance your traffic over these 4 links, for example. And by default, OSPF can do this on 4 equal cost multipath. But if you have more than 4 equal cost multipath and you want OSPF to load balance traffic over 6 interfaces, then you have to change this default behavior. And to change this default behavior, in the OSPF router configuration, we say maximum path, and you mentioned your maximum path. For example, in this case, we say maximum path 6, and then OSPF would be able to load balance your traffic over 6 paths. The last 2 commands, at this stage before verification commands, I want to talk about are related to the commands that manipulate the whole OSPF process. The first one is the command that shut down the whole OSPF process on your router. So, for example, if you have a router OSPF with the ID of 1, you go to your desired router ID, OSPF ID, sorry. So you say router OSPF 1, router OSPF 2, etc. And then you run shutdown command. And this will bring the whole OSPF process down on your router. So if it is a in production router, I would 100% do not recommend you to do it unless you want to have a outage window, etc., and then run this command. And once you did whatever you need to do, then you can bring it back up through no shutdown command. And in some circumstances, you may need to restart the OSPF process to restart the OSPF if there is an issue with the neighborship and you want to restart OSPF process, etc. For whatever reason, if you need to restart your OSPF process in the privilege mode, you say clear IP OSPF process and then press enter, and this will restart the whole OSPF process on your device. Now it's the time to run the verification commands and make sure OSPF work. So I'll do this on a fast forward status. You can see that as soon as the interface came up, something happened. OSPF adjacency change. Process ID 1, neighbor 192.168.2.1, this is the router ID, and gigabit 2 changed from loading to full. So this means that we are good between router 7 and router 1. To verify your OSPF, we have multiple commands. The first one is checking if our neighborship is in the right status with the neighboring router. And that is show IP OSPF neighbor, if I can type it correctly. Show IP OSPF neighbor will show you the details of your status with the neighboring router. What is the router ID of that neighboring router? What is the status? It is in full status, and this is the dead time, and this is the IP address of the interface, which is 192.168.1.2. You saw that router 1 had two IP addresses, 1.2 on gig 2 and 2.1 on gig 1. And we didn't configure the router ID or loopback address on this router. So the router picked 2.1, which is bigger than 1.2 as the router ID. And this is the IP address of that neighbor, which is 1.2. And then the interface is gigabit Ethernet 2. If you have multiple routers, you can customize this command and mention your router ID, I mean your neighbor router ID here, and customize this command and get more information as well. Neighbor is this, the interface is this, interface ID is something, and in the area 0, this is the area ID, and DR is 0 and BDR is 0. We don't have any DR and BDR here. Why? Because we configured these two in the point-to-point situation. And this is the time that neighbor has been up, and this is the dead timer, 37. You can see that if you run this command again, this will be changed to 39, and once it goes over 40, it will be reset every 10 seconds. You can also customize show IP OSPF neighbor for the specific interface. So we can say show IP OSPF neighbor, and the neighbor that is connected to gigabit Ethernet 2. We only have one neighbor here, but in situations you have more than one neighbor, you can customize this command for a specific interface as well. The next verification command will show you on what interfaces of this router OSPF is being enabled. So we say show IP OSPF interface, and it shows you the list of interfaces that you have OSPF enabled with details. For example, here it shows you Gigabit Ethernet 2 and also Gigabit Ethernet 1. If you just want to have a brief list, you can run this command with brief at the end, and it shows you a short or brief status of your neighbors, or sorry, interfaces that have OSPF enabled. And you can see that here, Gig 2 with the process ID of 1 is in area 0, and this is the address and this is the cost, and its state is, as you can see, P2P. And then Gig 1 is in area 2 and it is a BDR or backup designated router. If I run the same command on router 3, I just want to show you something. So if I go to router 3 and run show IP OSPF interface brief, you can see that it says the status or the state is DR off, which is DR other. When you have multi-access OSPF networks, the routers will be either DR, BDR, or DR other. DR other routers are the routers that are not either designated router or backup designated router. With the setup we had, I'm expecting router 4 be the designated router. So we check that show IP OSPF and then interface brief. You can see that this router is DR because we changed the priority of this router and now this router is DR. So with this scenario, router 6 was backup designated router, router 4 is the designated router, and router 3 and 5 will be DR other. And also again, you can customize this command for a specific interface. For example, interface gig 1 and get all of those details for this specific interface if you have multiple OSPF interfaces. The next command is show IP protocols. Show IP protocols is basically for not only for OSPF, but it shows all dynamic routing protocols you have configured if you have configured more than one, or if you have run multiple OSPF processes, for example, on this router. Anyway, this one, for example, shows you that you have routing protocol OSPF 1 here, and the router ID for this process ID is this one, and the number of areas on this router is 1. What is normal, stub area, or NSSA, which is out of CCNA topics. A maximum path is 4 configured for this routing protocol, and these are the networks that are handling by this network, and what is the source of these routes, and etc. The next command is show IP OSPF. This command will give you a lot of information about the OSPF process that is running on your router. For example, what is your process ID, what is your router ID, when did this process start, and like some other information. For example, if this router is an area border router or not. If I can find it, yeah, it is an area border router and also an ASBR, and some other information that can be useful for troubleshooting purposes. And some other information like number of LSAs in the routing in the LSDB, and what information about area 1, area 0, and etc. And if you have more than one OSPF process running on this router, you can customize it for a specific OSPF process based on its ID as well. So if your OSPF process ID is 1, you can say show IP OSPF 1, and it gives you information about that specific process ID. One of the most useful troubleshooting commands for OSPF, in my opinion, is show IP OSPF database. Basically, it shows you all of that LSDB we talked about and the LSAs in your database, and you can verify if the right LSAs is being advertised through the network, and these are the routes and the LSAs that needed to be advertised through the network and learned by this router, and etc. So you can verify what networks is being advertised in what area and who advertised it, and etc. The last but not least troubleshooting command is our beloved show IP route, because the eventual outcome of the OSPF is advertising the routes. So we need to make sure that if the right routes has been advertised through OSPF and OSPF was able to pick the right path for a specific destination or destinations. So I say show IP route on this interface, and we need to learn something. We have the static routes. The routes that have the O codes are coming from OSPF. And in front of O, because we have multi-area setup, you can see some other stuff as well. IA. IA is for OSPF inter-area routes. So this router learned 10.0.10 and also 10.0.20 from other areas, which are coming from area 2. And also we have 192.168.4.0, which is coming from another area. So with this code, you can figure out if this is an inter-area route or intra-area route. As always, you can customize show IP route for specific types of routes. So for OSPF, we can say show IP route OSPF. I want to see OSPF routes only. What I wanted to show you on router 4 was this one. You can see that default information originate we ran on router 7 caused this route to be installed in the routing table. And you can see that it is coming from OSPF still, and it is an E2 type. It is OSPF external type 2. What is E1, E2, etc.? It is out of CCNA topics. You can learn it on CCNP routing stuff. But just know that default information originate causes router 7 to advertise this route to the rest of the network. And on router 4, you can see that it is connected through gig 1, and the next hop is 192.168.4.4, which is router 6. As I mentioned before, routing works hop by hop. So router 6, if we jump on router 6 now and have a look at the routing table on router 6, you can see that it has to be, for that default route, it has to be router 2. And you can see that it is 3.1, which is router 2. If we jump on router 2 and check that default route, you can see that it is going to router 1, and finally router 1 will send the same, will have the same route, sending the traffic to router 7. So but by only one command, we advertise this default route throughout the whole network, and all of these routers now know who will be able to route them to the external networks. Same customization command for a specific subnet here works as well. So if we say show IP route, for example 0.0.0.0, I want to see where does the default route point on this router, and you can see that it gives me the information. This route comes from OSPF 1. The distance is 110, which is that administrative distance we talked about. The metric is 1 and other information about this specific route. Where to go, gigabit 0, gigabit 2, and what is the next hop is 192.168.3.1. Our OSPF configuration marathon is finished. We learned a lot about how to configure and manipulate OSPF for different scenarios. In the next video, I'll be talking about first hop redundancy protocols. I wish you enjoyed today's video and see you in the next ones.